All right, I'm going to show you how to do the calculations to figure out how to make a solution, and then the calculations once you have that solution to figure out how to dilute it. So over here on the left, I have written down 4 solutions I want to make. If you look carefully, you'll see that they vary by a factor of 5. So the most concentrated solution I want to make is 0.02 grams per milliliter of NaCl. This usually in chemistry we express concentrations in molarity, but for this experiment we're going to keep it in grams per milliliter because it's a little simpler. The first thing I have to figure out is how much of these solutions I want to make, and so I'm going to say I want to make 50 milliliters of each of the solutions. And so when I'm doing a dilution, which I'm going to do, I always want to make the most concentrated solution first, because you can't make a solution more concentrated. You can only make it more dilute. So I'm going to make the most concentrated solution, and then I'll dilute that one down for my subsequent solutions. Okay, so my most concentrated one is the first one, number 1 right here, 0.02 grams per milliliter of NaCl. So I do this, I say I have 0.02 grams of NaCl for every milliliter, and I know that I want to make 50 milliliters of that solution. So I'm going to multiply that by 50 milliliters. So I'm saying there's 0.02 grams of NaCl in every milliliter, and I want to make 50 milliliters. So how many grams of NaCl do I need? So I can cancel out my milliliters, and if I do that math, I'll find I need 1.0 gram of NaCl. Okay, so when I make this 50 milliliter solution, I'm going to use 1.0 grams of NaCl. So if I write my sort of recipe, I'm going to, oops, didn't want to do that. I'm going to have 1.0 grams of NaCl, and I want my final solution volume to be 50 milliliters. So you want to be a little careful with your words here. I'm not adding 50 milliliters of water, but I'm going to add enough water so that the total volume is 50 milliliters, because I have to keep in mind that NaCl will take up a little bit of space. So I'm going to say fill with, we're going to use deionized water to 50 milliliters. Okay, and then once I mix those, I'm going to have my 0.02 grams of NaCl per milliliter solution. Okay, so that's my most concentrated solution. Once I've made this, I want to take a little bit of it to dilute down to make my other 3 solutions. So the second one I'm going to do is, I'm going to write number 2 here, the 0.004 grams per milliliters. And so when we do a dilution, we use an equation that makes this actually very, very easy. And this is the equation. C1 V1 equals C2 V2. And in this equation, C1 is the concentration of whatever I'm starting with. In this case, it's our stock solution. So sometimes we call our most concentrated one the stock solution. So C1 is the concentration of our stock solution, which in this case is the 0.02 gram per milliliter of NaCl. V1 is the volume of the stock solution that I'm going to use to make my new dilute solution. C2 is the concentration of the new solution. So this is what I'm aiming for. And then V2 is the volume of the new solution. Okay, so I already know that C1 is 0.02 grams per milliliter of NaCl. I know that C2, the concentration I want to make, is 0.004 grams per milliliter of NaCl. And I'm going to say that I want 50 milliliters of this too, so I know V2. V2 is 50 milliliters. Okay, so I can rearrange this equation to solve for V1, which is what I really want. I want to know how much of the concentrated solution I need to add to get 50 milliliters of my new solution. So I'm going to rearrange this equation to solve for V1. So V1 is C2 over V2 over C1, okay? And now I can just plug in all of the numbers that I know and solve for V1. So I'm going to put here V1, move it over so I have room, is going to be equal to 0.004 grams per milliliter NaCl times 50 milliliters. And the concentration of my stock is 0.00, it's not 0.02, 0.02 grams. Okay, and I can see here that these units are going to cancel with those units. And so my final volume, move this up a little, will be 10 milliliters. Okay, so what this is telling me is that when I use my more concentrated solution, I'm going to use 10 milliliters of the more concentrated solution. And same thing as before. I want to fill with deionized water to get a 50 milliliter total. Okay, so those are my instructions. I'm going to use 10 milliliters of my more concentrated solution, fill the rest with water, and then I'll have 0.004 grams per milliliter. Okay, I'm going to do the next one. And in the next one, I'm actually going to use this solution I just made in order to make the next solution. Okay, and so these are called serial dilutions, where I'm taking one solution, I dilute it, and then I use that dilute solution to make my next more dilute solution. And you can see why this would be useful, right? Because by the time I get down to my most dilute solution, this one here, the 0.00016 grams per milliliter, I may have to, if I wanted to make that from scratch, I may have to mass out so little NaCl that it's really hard to get that small amount of NaCl. And so if I do serial dilutions, it works a little better and I get better accuracy. Okay, so this is pretty easy now. As I go to make my third solution, I write my 3 up here, which is the 0.008 grams per milliliter. I'm going to plug that value right back in to this equation here. Okay, so I want to know how much of the solution I just made to make the 0.008 grams per milliliter. I'm going to make 50 milliliters again. Okay, I'm making 50 milliliters for all these solutions. And I'm going to use the 0.004. Okay, so again, I can cancel my units. And if I did that, I'm going to write, so my volume is 10 milliliters again. Okay, so remember I told you at the beginning, for all of the solutions I'm making, I'm diluting by a factor of 5, right? So as long as I'm diluting by the same factor, it's going to be the same. It's going to be the same recipe each time, right? So for my next one, I'm also going to use 10 milliliters. So for this new solution, to make 0.0008 grams per milliliter and NaCl, I'm going to use 10 milliliters of the 0.004 and then I'm going to fill with DI water to 50 milliliters. Okay, so when I go to do my next one, which I'm not going to actually do, you guys can do that yourself if you want to. My next one would be the last solution, the 0.00016, this one here. When I went to do that, I think you'll find that I also am going to need 10 milliliters of the solution number 3 in order to make that work. All right.